Hello everyone, my name is Isan Dalgic. I'm an application engineer for Hioki USA, and today I'd like to talk a little bit about electrochemical impedance spectroscopy, what it is and why it's important for analyzing a battery cell. So within a battery cell there are a number of different electrochemical processes that are taking place, and a battery cell really is not a linear system. So some of these reactions take place very rapidly and some of them take place very slowly. The slowest process is the lithium-ion diffusion within the electrode. Next we have charge transfer reactions, which take place a little bit faster. And finally we have the lithium-ion migration within the electrolyte, which is the fastest reaction. So when we excite a battery using an AC test signal for when we're measuring the impedance of the battery, depending on the frequency that we use, we're essentially exciting those different processes that are taking place. For instance, at the lower frequencies, we are observing the slower reactions. And as we increase the frequency, we're now observing the faster reactions that are taking place within the battery. So electrochemical impedance spectroscopy, in a way, gives us the ability to peer into the battery in a completely non-destructive way. So when we take measurements of impedance of a battery over a range of frequencies, starting from high frequencies and going down to the lower frequencies, and then we plot the negative reactance against the resistance, we end up with a plot which is known as a Nyquist plot or a Cole plot. Now the Nyquist plot, you can see three distinct regions. Starting with the higher frequencies, the first region is the lithium-ion migration in the electrolyte. The circular area is the lithium-ion transfer reactions, and the 45-degree angle shows the lithium-ion diffusion within the electrolyte. From this data, it's possible to create an equivalent circuit model of the battery. So what's so important about this? Well, this type of analysis is important because you can really find out what's going on inside the battery. And so various processes can be tweaked to make improvements, etc. It's kind of like dissecting the battery and observing what's going on without actually physically opening it up. So it provides a safe and non-destructive analysis method of observing the behavior of an electrochemical system. And with the data that we obtain, we can create an equivalent circuit model that describes the electrochemical system. Hioki makes this type of analysis very easy. And here we have the BT4560. This is our battery impedance meter, and it's connected to a typical pouch cell. And we have a laptop here for running the PC application. A Nyquist plot can be generated with just a few clicks. And thank you for watching this very brief introduction to electrochemical impedance spectroscopy. So for this and other battery testing solutions, please contact us at the link below. And also, don't forget to like and subscribe to our YouTube channel. And please leave your comments below. Thank you.